Hello everybody. Today we're going to look at Kubernetes, or more to the point, the bits about Kubernetes that you need to know for the AZ-104. Because Kubernetes is a huge subject and will take you a very long time to actually master. This is a very brief overview to see how Kubernetes works in Azure, the commands that you'll need in Azure to pass an AZ-104 exam, and the level of understanding that you'll need for just to pass the AZ-104 exam with Kubernetes. This will also lead you into being able to go and further study Kubernetes. So let's get on with it, shall we? Okay, so a little bit of history about Kubernetes. So Kubernetes was originally a system developed by Google. Yes, that Google. That Google developed Kubernetes to run Google. So this thing is huge, okay, in the fact that this thing can scale. And it can scale to, well, the Kubernetes guys, they like to say that it can go to planet scale, okay? So you're not going to run out of capacity with a Kubernetes cluster, but a Kubernetes cluster can also be very small. You can run a Kubernetes cluster directly on your local hardware, on your local desktop or your local laptop without any issue whatsoever. You can even run this on microscopic tiny little devices like Raspberry Pis, and they will perfectly happily run as a Kubernetes server. Okay, so what do we really need to know about Kubernetes for the level for the AZ-104? Because this is a giant subject. If you go and start to study it, you will end up at a bottomless pit of information. You'll never hit the bottom with it. There are independent certifications for Kubernetes, and if we actually go and look at the kubernetes.io website here, if we go and look at the kubernetes.io website here, you'll see that they also say this thing is planet scale, but there is also training for Kubernetes, and there is actually a Kubernetes Cloud Native Associate, a Kubernetes Administrator, a Kubernetes Application Developer, and a Kubernetes Security Specialist. Each one of those is going to take a very long time for you to study. Now, as a component of the AZ-104, let's talk about what this thing actually is and what it actually does. So, Kubernetes, or people abbreviate it to K8S, is actually what is known as something called a container orchestrator. Okay, so what does that mean? It basically means that Kubernetes is to Docker containers, or containers in general, as VMware vSphere is to virtual machines. So with things like VMware or even Hyper-V, if you've got one or two machines, you might independently manage those with basic consoles. But when you start scaling to hundreds or thousands of machines across multiple different data centers, even globally, you're going to need some sort of management tool. That sort of management tool is going to be something like vSphere or System Center Virtual Machine Manager. So it's the same with Kubernetes. Kubernetes doesn't really do much on its own, but it takes containers, runs those things for you, and manipulates all the networking inside it, and all the security inside, and all the authentication inside, and all the scalability and elasticity that you might need. So to really understand this, we really need to look at the terminology. Yeah, sounds about right. Terminology. So Kubernetes initially has something called a node. In fact, Kubernetes can have lots of nodes. So what is a node when it comes to a Kubernetes cluster? A node is a thing. It's a hardware piece or a software piece. It's something that can run a container. So a node might be, for example, something like a server, like a bare metal server. It might be a virtual machine. It might even be something like a Raspberry Pi. In fact, if we go and look at people who are building lots of Raspberry Pi clusters, these lovely things down here, there's many different types of cluster software you can run on something like this. But one of the most common things for people to do is to actually run Kubernetes on these, and each one of these individual Raspberry Pis here are going to be running as a Kubernetes node that will be able to run some containers on it, in the same sense that you're going to need a series of servers to run things like virtual machines with VMware. So to control this system, what each of these nodes actually has is it has an etcd database. Now, an etcd database, again, hellishly complicated thing. Think of it a bit like the databases you get with Active Directory domain controllers. They're multi-master replicated. These are containing a list of instructions for what these nodes are supposed to do. Kubernetes is inherently a pull system, not a push system. So you give it a list of instructions and let it get on with it. And eventually it will reach the, desired configuration that you have actually given that Kubernetes cluster. Now, to do this is all controlled by the Kubernetes API. Okay, there is actually a service. There's a K8s API. This thing is actually a container, and it's a container that actually runs on top of your Kubernetes cluster. I'm drawing it to the side here for sake of simplicity. In reality, it is managing itself. This thing is controlling these nodes underneath. And this is what we use to then feed instructions to our Kubernetes cluster. Now, to talk to this thing, does Kubernetes have a GUI? Well, the answer to that is yes, but no. In the sense that the Kubernetes API is normally hit with commands, and it's normally hit with API calls. There is a GUI for it, and if you go to the Google images, and you're going to have a look for that, and you go and look for Kubernetes GUI here, Kubernetes, you'll find there is actually an official Kubernetes GUI. Just take a quick sip of tea there. Today we are drinking mostly Assam tea from India. Very, very nice. So this here is the official Kubernetes GUI. It has to be installed separately. It doesn't come with Kubernetes, but there are so many different GUIs that you can use to interact with this thing. I mean, here's one called Octant. Okay, cool. Here's one called a Lens. All right, that's fine. What else have we got down here? Here's another one, Kubevius. Okay, that's fine. What's this one down here? Constellate. Okay, that's cool too. Oh, there's another one there, Kubernetes. The point is, there is a lot of different GUIs for Kubernetes, and there's also a specific Azure GUI as well that Microsoft have actually created for this. We're not going to interact too much with the Azure GUI, but we're going to have a look at it. Because the way that you need to know how to interact with this thing is via commands. And the command that's actually used is something called kubectl. Okay. Now, some people call this kubectl, but I personally think they're insane because to me that says kube control. But still, kubectl. This is the command that we actually use to go and talk to our Kubernetes cluster and deploy things to that Kubernetes cluster. Okay. So let's go and have a look at this. Let's go and set this phase up first, and we'll come back and we'll continue this drawing in a moment. So let's drop into Azure and let's go and create us a Kubernetes cluster. So if we go into temp down here, I've got a temp resource group, that's fine. We're going to go Kubernetes and we're going to go into Kubernetes services here. Now, we've got no Kubernetes services at the moment, so we're going to create a new Kubernetes cluster. So within this Kubernetes cluster, I'm going to drop this into temp. Again, just like a lot of the things in Azure, there are many, many, many settings inside here. Not all of them I will ever go over at all during this video, but there's a lot of documentation for this. So I'm going to call this Kubernetes cluster myKube. Yeah, I'm going to deploy this to UK South. And what I'm going to do is I'm going to leave this on a manual scale method with 2 nodes. So we're basically going to be producing this. In fact, inside Azure land, the nodes here are actually virtual machines. In fact, they are virtual machines that are a part of a scale set in Azure with a defaulted Linux-based operating system on it. That means you can add more nodes very, very easily. You just have to scale the scale set. So I'm going to go in here, and this is going to be a node pool because Kubernetes can control multiple sets of nodes. I'm only dealing with one at the moment. That's fine. The access is going to be completely local. That's fine. We can layer on different ways of doing authentication to Kubernetes, including Azure AD. And within networking, this is one of the most important things here, KubeNet or Azure CNI. KubeNet is Kubernetes' internal networking solution. It works perfectly fine. Azure CNI is Azure Container Network Interface. I think that's right, Container Network Interface. This means that you can plug this Kubernetes cluster into a VNet in Azure and have your containers receive IP addressing and networking information from your existing VNets. I'm going to stick with KubeNet. Just bear in mind, you've got to pick this one correctly at the start. You cannot change this afterwards. You would have to go and rebuild everything. Okay. I'm not going to bother with container monitoring because this is just a basic demo and we could go on for hours about all of these different features. So I'm not going to bother tagging it either. We're just going to create this. So a very simple Kubernetes cluster created called myKube. And let's go build that thing. Okay, that's going to take 5 minutes to deploy. While that's deploying, and it's got the deployment in progress, we're going to drop back over to here. All right, so how do we feed this thing containers? Okay, because that's the core thing that this runs on. It is containers. Containers. My whiteboard is lagging a little bit. Well, we have to talk to this kubectl command. How do we use the kubectl command? We could use this locally on my desktop computer. I could drop into a terminal down here and I could use the terminal to produce what I need to produce. Is my camera going wonky? So I could use the terminal to actually connect to this with kubectl and connect to it over the web, but I'm not going to. The easier way of doing this is to actually connect to kubectl by using the Cloud Shell, because the Cloud Shell in Azure has all of this nicely installed for me already. So we are going to feed this kubectl command a file, and that type of file that we're going to feed it is we're going to feed it a YAML file. So YAML just means yet another markup language. A YAML file is literally just a text file. That's all it is. And it contains information about how I want my deployments to work. In fact, this thing contains information about the containers I want to deploy. It also contains information about the networking for those containers, and it contains information therefore about port information and whether I need a public IP address. It also contains things like volume information. It contains a lot of stuff inside here. Okay, YAML files for Kubernetes are quite long and quite extensive. But at the core of it, a Kubernetes deployment or Kubernetes application, two things. You need a deployment and you need a service. Okay. So when you feed a YAML file in here, initially you feed in something called a deployment. Now, deployment is going to spread across multiple nodes. And inside a deployment, what you will actually find is you'll find individual pods. Okay. So each pod is going to contain your actual containers that are running. Now, you normally have one container per pod, but you can actually have multiple containers per pod depending on how you've configured this to run. The thing is, though, deployment itself won't actually work on its own. What you need to do is feed traffic into it. There is another layer above this, and that layer is known as a service. Now, a service will sit across these nodes as well. What a service will do is it will route traffic. So a service might have, for example, a public IP attached to it if this is running in something like Azure. This will then actually route traffic to these underlying pods. So if a user comes along and connects to that public IP address, they will be routed to a container in one of those pods, and the same for another user, a bit like load balancing inside here. The thing is, though, there is one very, very important component here with Kubernetes, and that's how these things link together. So the Kubernetes service and the deployment down here link via labels. Okay, so if you're in the habit of not tagging or not labeling things inside your environments, now is the time to do it. Because if you do not label your services and your deployments, your services will not be able to actually connect to your deployments. Labels are very important. If you don't label things, nothing will work. Okay, so what I'm going to do now is I'm going to deploy an Nginx web server to my Kubernetes container. Kubernetes cluster. If you don't know what Nginx is, it's a very, very basic web server, very tiny, very low on memory, but can scale incredibly well with containers. So back here, I now have my MyCube set up, and you'll see we've got a number of things created for it. We have an API server address, we have some networking built for it. If we try and connect to it though, it gives me a bunch of commands and instructions for how to connect to this thing. So you'll also be able to see on here, there are already existing workloads like Core DNS and Connectivity Agent and Metric Server. There are already containers that are here to manage Kubernetes already existing on Kubernetes. So what I'm going to do is I'm going to drop into my dashboard here. Now, if you're wanting, not my dashboard, sorry, I'm going to drop into my Cloud Shell to connect to Kubernetes. Now, if you want to pass the AZ-104, you're going to need to know a couple of commands. These are those associated commands. I will put them into the YouTube description for you later on. First command we're going to need is this lovely one here, AZ-AKS get credentials, because even though I have the kubectl command inside my Cloud Shell here, I still need to actually connect to it. So by using the AZ-AKS credentials, what I can do now is I can actually use this command to connect to the correct resource group and the name of my Kubernetes cluster. And now I can type kubectl and it won't error out on me. Kubectl will now actually allow me to run other commands like, let's clear that, kubectl get nodes. And I can see my two nodes that are part of my Kubernetes cluster. If I do kubectl get deployment, you'll see I've got no resources found in that default namespace. I've got no deployments. So let's go make some deployments. Here in my AZ-104 notes repository, I have a couple of YAML files, a web server YAML file and a web server service YAML file. Now, you'll notice a few things about these YAML files, okay? First of all, what this is actually going to do is it's actually going to deploy a container image called Nginx Alpine, and it's going to deploy it with a container port of port 80. It's also going to request 3 replicas. There's going to be 3 copies of this Nginx web server running inside Azure, or running inside my Kubernetes cluster inside Azure. We've also got webserver-svc.yaml. This is the thing that's going to be providing that external connectivity. You'll notice the spec type is node port, the port is running over 80, and the selector is using app of Nginx. This selector down here is actually hooking in to this label here. Okay, that's what it's actually looking for. So this label component is very, very important. I have these same files actually loaded here on my Cloud Shell. So if I go into cd az-104-notes here, and I go to Kubernetes projects, do an ls again, you'll notice I have the same files here, webserver-svc and webserver.yaml. So if you do cat webserver.yaml, you can see it's the same file. So what I'm going to do now is a very, very simple command, kubectl create -f, the F is for file, ./webserver.yaml. And that is going to create the deployment of the Nginx server. So if I jump back into my Kubernetes cluster here, and I go and have a look at my existing workloads and refresh this, you'll notice I've got web server. I have 3 copies, it's updated 10 seconds ago, and I have 3 Nginx web servers running here. I can't connect to these web servers yet. I need to put a service in front of them. So let's go and create that service, which was defined in the svc YAML file. If I go and run that, we now have that defined there too. So we can now do something like this. We can do kubectl get nodes, and we can see our 2 nodes. We can do kubectl get deployment. We can see we have a web server deployment, and we can also do kubectl get service. Okay, and you'll notice this get service command here has very nicely for us given us a load balancer with an external IP address attached to it. This is the external IP address for that Nginx web server. So if we go and grab that IP address and throw that directly into a web browser here, we can see welcome to Nginx. If we drop back to our web server here, or back to our Kubernetes cluster, sorry, we can see inside the services and ingress, we have web server service with that appropriate external IP address. We also have here inside the workloads, we have web server down here ready, and there's 3 copies of it. Now, one more thing you do need to know for the Azure exam is how to scale one of these services now it's actually up. So if we drop inside here, we drop back, let's just move that over to the side a little bit. Okay, so we're going to do a little trick here. I'll say it's a little trick. Watch this replicas, 3 desired, 3 updated, 3 total, and 3 available. Okay, so what we're going to run is this next command from my list of commands, which is kubectl scale. So if we go and pop this command inside here, kubectl scale, what I'm going to do, whoops, I need that later. I'm going to say my deployment, which is called web server. I've got replicas 3. I've already got 3 replicas. Let's go and change that to 6. Whack enter. Scaled. Refresh that. I've now got 6 copies of Nginx running. What about if I want real high scalability? Let's change that to replicas of 50. Deployment scaled. Let's refresh that. 50 desired, 50 updated, 50 total, and 6 available. It's pending on all of these, but if I refresh, that number is going to slowly tick up. I've already got 19. Let's refresh that again. I've already got 40. Let's refresh that one more time. 48, and then 50. I've got 50 Nginx servers. So if I go and refresh this, I've still got the same Nginx welcome screen, but it's now being load balanced across 50 different containers. It's very, very quick to bring that sort of stuff up. Now, there is another question that normally arises at this point, which is, okay, that's fine. How do I automatically scale this and crash it down? Well, you can't. All right, I thought that was the whole point of Kubernetes. It is, but you do it with other tools plugged into Kubernetes. Kubernetes is very much just an engine, okay? That's why there's so many GUIs out there, so many metric services out there, so many different ways of monitoring this thing and poking and prodding at it with different pipelines and all sorts of fun DevOps tools. You need a lot of structure around Kubernetes for it to actually work. In fact, if you think about it, when you've actually got if you go to the car analogy, right? If you go and buy a Mini Cooper, okay, something like that, you're going to get a nice car. It's going to get all the bells and whistles that you need. It's going to have some GPS and some wheels and some heating and some air conditioning and all the things that you want. That's fine. It is a car, right? You've also got this other end of the spectrum, which is something like a Cater 7, okay, something like that, which is basically just an engine and some wheels. This is more what Kubernetes is, okay? There's nothing really attached to it out the box. You have to go and build stuff, which is also why you find people like Red Hat, OpenShift, these kind of products out here. So this, for example, makes orchestration easier. You may have heard of OpenShift, but not really seen what it actually does. What OpenShift is doing is it's using Kubernetes underneath, but it's welding around that all of those monitoring tools and scaling tools and elasticity tools and authentication tools around it. Okay, making it very much a full serviced product. Again, massive rabbit hole to go down there to learn something like Red Hat OpenShift. For the AZ-104, we just need a very base understanding of what Kubernetes is. We do not need to be an expert with them. We need to know how to deploy a Kubernetes cluster in exactly the same way that I've shown you here, and how to do very basic deployments from existing YAML files, and also to be able to do some things like get nodes, get deployment, get service, and actually scale an existing deployment, because they may ask you some very basic questions on some of the commands of a Kubernetes cluster. And that completes the AZ-104 section for a Kubernetes overview. I hope you enjoyed this video, and you'll join me next time. And you know the routine, hashtag like and subscribe, and I hope you enjoyed this video and will join me next time. Goodbye.